Students, welcome to the YouTube video lectures. Today we are going to solve complete solution for chapter number 19, which is magnetism. Question number 1, please. A charged particle is launched with a velocity of it's given to you. This is the velocity at an angle of 35 degrees with respect to magnetic field B, 4.5 millitesla. This is milli means 10 raised to minus 3. If the magnetic field exerts a force this much Newton on the particle, determine the magnitude of its charge. So you have to find out the magnitude on the charge. You know that the force on a charged particle with charge Q moving with velocity v in magnetic field B is given by QVD sine theta. Okay, so you have to find out Q you have to find out, so it will give you Q is equal to force, take all these in the denominator, VB sine theta. So Q is equal to force is given to you, velocity given 10 raised to power 4, B magnetic field 4.5, Tesla means 10 raised to power minus 3, and theta 35. So you would get 19 into 10 to minus 6 coulomb, and you know that 10 raised to minus 6 coulomb is equal to 1 microcoulomb. So this is microcoulomb. Next, number 2, an electron, mass is given and charge given, moves with a speed of, it's also given, in a circular path perpendicular to the magnetic field. So the charge is moving in this direction, and this is the magnetic field, so perpendicular. So theta is given 90 degree. Find the magnitude of the magnetic force on the electron. So again the same rule, force on a charged particle Q moving with velocity v in magnetic field B is given by this rule. So you have to find out F directly in this case. Charge is given, velocity, yes, B sine 90. So you get force 3.20, 10 raised to power minus 14. This is your answer. That's number 2. Then number 3. wire of length 0.0150 carrying a current of 9.5 ampere is affected by a magnetic field. Okay, 0.845, okay, is placed in the magnetic field. Okay, the angle between the direction of the current flow and the magnetic field is 25 degree as shown. What is the magnitude and direction of the force, magnetic force on the wire? So we know that the force, magnetic force on a wire of length L with current I in the magnetic field B is given by this. So this is the force on a current carrying conductor, in fact. So you have to find out magnitude and direction. First, magnitude I 9.5, B L theta. You get how much? 0.051. This is the magnitude. About the direction, direction will be out of the page or out of the board. Okay, if you have these two, for example, this is current direction, which is the length vector, this is magnetic field, like this one, if I'm working on my piece of paper. But since I'm working on this board, so it will be like this one, from I to B, it should be out of the board or out of the paper if you are working on the paper. Next, this one will finish, huh? Okay. Number 4. A 3-meter long straight wire carrying 6 ampere current and directed in the x direction positive is influenced by perpendicular magnetic field. Okay. The magnetic force on the wire is given, directed in the negative direction. Okay. If we take, this is two-dimensional space, both. This side I take x-axis positive, this side I take y-axis positive. Okay, and this one I take y-axis, z-axis positive. Now, this is along the negative y-axis. Okay, force negative, this positive, this one negative. Okay, now you have to find out the magnetic field B. We have this one. You need magnetic field B, magnitude and direction. First of all, magnitude. Okay. Right. You see, for the direction, let's decide the direction first. Okay. So x-axis is the current direction, the length vector, right? And like this one. Okay. So this is right of the paper, right of the paper. This is down, okay, and this y-axis is upside. right? Now, the direction of B will be out of the paper. Direction out of the paper or out of the board right now. Okay? So, like this one. Okay? Because this is length vector, which is current direction, and this is the force in the thumb given down, so it should be out of. So from current direction to magnetic field B, force is given. So this is given I direction, this force is given. So we always move our right hand, this is rule number 1, from the current to magnetic field without changing I direction and without changing the force direction, which is down. So magnetic field B is out of the paper or out of the board. So force, how much? 0.36, current 6, L, how much L? 3 meter. Okay, and sine of 90 degree, because angle is 90. This is current and this is out of the paper B, so angle is 90 degree. So B, you get finally 0.02, and direction like this one. Okay, like this one. From the current to magnetic field out, and force is down, which is given to you. Good. Then, next question, please. In each of the figures A and B below, find the direction of the current in the wire that would produce magnetic field. Now, we'll be using right hand rule number 2 here. What we do, if this is the conductor, for example, current is upward, we keep right hand thumb in the direction of the current, and these curved fingers give the direction of the magnetic field. If the current direction is reverse, magnetic field direction will be reversed, circular magnetic field lines. Okay, this is your conductor, for example. Okay, and you know that this we use into magnetic field into, and the dot we use out of, right? For example, this is the conductor, this is into, so I have to use magnetic field direction into, and this side out of. So what does it mean? Because if I use my right hand like this one, it will be wrong, because this into, but this is out of. So I have to use like this one. Okay, this is conductor here. Forget current direction, because current direction you have to find out. So right hand rule number 2, this is into, out of, this side out of. So current direction is to the left. Done. Okay. Then next here. Okay. This is the conductor, for example. Current direction you need it, and magnetic field direction given. Right hand rule number 2. If I use like this one, it will be wrong. Like this one. So magnetic field lines in this direction, anti-clockwise. So this thumb out of paper or out of board. Right now I'm using the board, so I write board. So once you are working on the paper, so out of the paper. So current. Let me use the here current out of the paper, and here left side. Okay, left side. That's it. Fill in the blanks. Number 6 question. The geographic north pole of Earth corresponds to a magnetic south pole, because once we say you have north pole, meaning it is south seeking, looking for this opposite pole. So south. SI unit of magnetic field is Tesla. And the magnetic force on a charged particle has maximum value when the charge moves in a direction perpendicular to the magnetic field. So perpendicular, which is, F is equal to Q B B sine theta. Sine have maximum 1 for 90 degree, meaning perpendicular. Right. The last question, please. Match the column. Like magnetic poles repel each other. Magnetic force on a moving charge in magnetic field is given by this rule. Force is equal to QEB sine theta. We did it many times. And the last one is magnetic force on a current carrying wire, IBL sine theta. Okay, so that's all about the tutorial questions for chapter number 19, magnetism. And see you in the next lecture. Thank you very much and have a nice day. Good luck.